Imagine you're making ice cubes for a party, but you're in a hurry. You fill one tray with hot water from the tap and another with cold water from the fridge. Which one do you think will freeze first? Most people would say the cold water, but what if I told you that the hot water might actually freeze faster? This phenomenon is known as the Mpemba Effect, and it's been observed and studied for decades. But why does it happen? Let's dive in and find out. The Mpemba Effect is named after Erasto Mpemba, a Tanzanian cook who noticed that hot ice cream mix would freeze faster than cold mix. Since then, the effect has been observed in many different experiments, but the exact cause is still not fully understood. Some scientists think it might have to do with the way that hot water evaporates more quickly, cooling the surrounding air and causing the water to freeze faster. Others think it might be related to the formation of ice crystals in the water. One key concept that might help explain the Mpemba effect is supercooling. This is when a liquid is cooled below its freezing point without actually freezing. This can happen when the liquid is very pure and there are no nucleation sites for ice crystals to form. In the case of hot water, it's possible that the rapid evaporation of the water creates a layer of cool water on the surface that can become supercooled, allowing it to freeze more quickly. Another factor that might contribute to the Mpemba effect is heat transfer. When you put hot water in a cold environment, it will lose heat more quickly than cold water. This rapid heat loss can cause the water to cool down and freeze more quickly. Additionally, the hotter water may also transfer heat to the surrounding air and surfaces more efficiently, which could also contribute to faster freezing. So, what does the experimental evidence say about the Mpemba effect? While the results are not always consistent, many studies have found that hot water can indeed freeze faster than cold water under certain conditions. For example, one study found that hot water froze an average of 10 minutes faster than cold water when placed in a freezer at -20 degrees Celsius. However, other studies have found no significant difference in freezing times between hot and cold water. Some researchers have suggested that dissolved gases in the water might play a role in the Mpemba effect. When water is heated, the dissolved gases are released, which can affect the formation of ice crystals. For example, one study found that degassed water froze more slowly than normal water, suggesting that the presence of dissolved gases can influence the freezing process. So, why should you care about the Mpemba effect? While it might seem like a curious phenomenon, it actually has some important implications for fields like cryogenics, materials science, and even climate modeling. For example, understanding how hot water freezes faster than cold water could help us develop more efficient methods for cooling and freezing materials. Several theoretical models have been proposed to explain the Mpemba effect, including models based on heat transfer, nucleation, and evaporative cooling. While these models can provide some insight into the phenomenon, they are not yet able to fully explain the complex interactions between the water, the container, and the surrounding environment. In conclusion, the Mpemba effect is a fascinating phenomenon that can teach us a lot about the behavior of water and heat transfer. While the exact cause of the effect is still not fully understood, research continues to uncover new insights and implications. Thanks for watching, and don't forget to subscribe for more mind-blowing science content.